Imagine you're sitting in a NOC. Suddenly, a customer calls you and says, the internet is not working. What will you do? Will you start changing the configurations? Will you restart the router? Will you change the routing protocol? Or simply start running some random commands? If you're going to do that, please don't do that. Because a good network engineer does not troubleshoot by guessing. A good network engineer always follows a systematic troubleshooting approach. So in today's video, I'm going to show you some 10 simple steps of network troubleshootings technique, which will be very useful to you in real world networks. So this is something on your screen which you're seeing right now is the golden troubleshooting method, which we'll be discussing. So always start your troubleshooting with the layer 1, that is physical layer. Over 70% of sudden network failures originate from damaged cables or loose pins or the hardware failures in the network. So always start your troubleshooting from physical layer. Something is going down, don't directly go and check or assume that there's some issue with the BGP or there's some issue with the OSPF. Check the physical layer. Before checking the routing stuff, ask yourself whether the cable is connected or not, whether on the links the LEDs are on or not. Check if the interface is enabled or not. Check if the device is powered on or not. And if it is not working, if you still feel, you can change the cable or you can change the port. Because I've seen there was an issue on which the network team was troubleshooting for the whole day. They were checking the routing stuff, the firewall rule stuff, everything. And at the end, they found that there was a bad cable which was getting connected to the firewall. So if you're very sure that there's some issue with the physical layer, go for that option. Change the port, change the cable. That is the best option you can do. So always remember, start with the physical layer. Now let's assume the physical layer looks good. Now you have to check the IP configuration. Now most of the time it happens that the client has configured a wrong IP address, or the client has not able to reach the DHCP server and it is not getting an IP address, or it is getting an APIPA IP address. Because I've seen one of my client was getting this IP address 169.254 something 1.5 or something like that. He was getting this IP address. So I soon found out this is an APIPA IP. APIPA is automatic private IP addressing. So this is basically a feature where the device is not able to get an IP address from the DHCP server, and then it assigns itself an IP address. So it's a self assignment IP address feature, you can say. So it was getting an APIPA IP address. So I found out it was not able to reach to the DHCP server. So we troubleshooted in that direction. So it is always very important to check the IP address of that particular client, whether that client is getting the IP address or not. Basically, I have shown over here, guys, this is a sample host IP profile. So you will check whether it is getting the IP address or not. You will check the subnet marks, whether the subnet marks is correct or not. Now here the subnet marks is 255.255.255.0. Now let's say the client is getting some other subnet marks. Okay, so that can also cause an issue. So you can check that. Check whether it is having the correct default gateway or not. I faced an issue where one of the client was able to communicate with the other clients which were in the same VLANs. So those were able to communicate with each other. but he was not able to communicate with the other hosts which are in the different VLANs. So the default gateway was an issue. It was not able to route its packet basically beyond the network or across the network. So at that time your default gateways comes into picture. So always check this default gateway. Of course you need to check the DNS server whether it is correctly configured or not. If the DNS server is not correctly configured, you may not reach to that particular domain name. So this is the sample host IP profile which you can check. IP address, subnet masks, default gateway and DNS server IP address. Now we move to the most useful and the most important troubleshooting tool, which is ping. Now if you are planning to be a network engineer or you are a network engineer, you know that ping is a very essential part of your life. It's a part of your life, right? So I'll always say that ping is the best friend of a network engineer. It's the best tool which a network engineer always use in its day-to-day work life. So this ping tool basically helps us to test the connectivity to the destination. So let's say if somebody comes and he tells that she is not able to ping a particular website. So what the first thing you need to check is to check whether it is able to ping its own loopback IP or not. That PC is able to ping its own loopback IP or not, which is 127.0.0.1. This basically will confirm you that yes, whatever the TCP IP stack is there, protocol stack which is running inside, it is working properly. The second thing what you can check is to check the local network card is functioning or not properly. So you can check by pinging its own IP address. So you can ping its own IP address and you can check that part. You can check the default gateway, as I told. If it is not able to communicate with the host in the other network, then you can of course check the default gateway. You can just ping the default gateway and check whether it is reachable or not. Then you can check this particular IP, ping 8.8.8.8. This is basically Google's DNS IP. So you can check this IP and make sure that it is this public IP, it is reaching to the internet or not. Then you can check of course the URL or the domain name for which it was not able to ping. You can check that ping also. So let's say if it is able to ping 8.8.8.8 but not able to ping google.com, that means there's some issue with DNS. So I'll come back to this point of DNS in our slide number 8. So we'll check this particular point of DNS. Traceroute. So ping basically gives you or tells you whether the destination is reachable or not. Traceroute will basically helps you to understand the path or the route from where the traffic is going. Now in Cisco you can use this on Windows you can use this traceroute command. On Cisco of course you can use this command of traceroute. Now this same traceroute command works on Linux and on Mac OS also. Okay, so now let's say you have a I'll just draw a diagram over here. Let's say this is your PC. Okay, this is the switch, this is your router, which is your default gateway. So I'll draw the diagram over here. So let's say this is your PC, this is your switch, this is your default gateway, and there's some network here, and this is your edge router, your ISP edge router, and from here the internet is getting connected to the whole of the internet. Now let's say you're tracing this some IP address, and you are getting the first hop as your gateway, which is this, and then the second hop as your ISP edge, but after that it is drop in. So by this tool, you can understand that from where the packet is getting dropped. Now here I understood that beyond the ISP edge, the packets are getting dropped. So I'll troubleshoot in that direction. I log in into this particular edge ISP router and then I can check. So this is very important tool to identify where exactly at which hop. So this basically, guys, represent the hop numbers. This 1, 2, 3, 4. So these are the hop numbers. So it shows the exact transit routers between the source and the destinations. Helps in identifying network loops. If there's some loops in there where your IP is getting, or your packets are getting looped between two hops, so you can identify that kind of issues. You can identify if there's a black hole router where there is no route itself. You can measure again the round trip response time, which is again to find out that what is the latency in case you are facing some latency kind of issue where you are where the end user is facing an issue where he's complaining that he's getting a lot of delay in opening a website kind of thing. So at that time also this Traceroute tool will help you a lot. Now we are moving deeper into layer 3 troubleshooting. So I'll tell you one rule. Always remember this thing, that a router can forward the packet. A router can forward the packet if it has a valid route to the destination. Routers need a route in the IP routing table to forward the packet to the destination. So you, on Cisco device, we can use this command, show IP route, to check the routing table, to check whether that particular destination is having a route or not. So the route will always have something known as the next hop. So sometimes it happens that it have a next hop, but that next hop is incorrect. So I've mentioned over here. Sometimes it happens that the route itself is not present. So of course the traffic is going to get dropped. Sometimes the router is configured with a default route. Now it happens that most of the times that your router will have a default route. Okay, so if the default route is incorrect, of course you will not able to reach the destination. Protocol flapping, I've mentioned this point because many times it happens that your OSPF neighborship or your BGP neighborship is flapping, and which is causing an issue. So of course this comes under your completely the protocol level troubleshooting. Now let's move forward. Now let's check the interface status. Now the people who are my subscribers, they know that my favorite command is this, show IP interface brief. I'll zoom on that command because this is my favorite command, and this is a very useful command if you're working on Cisco devices. Show IP interface brief, because this command will show you whether your switch port or your router's interface status, whether it is enabled or whether it is disabled, whether it is admin down, admin up, whatever. So basically it will show you. So this is the interface status metrics, I can say. So this basically shows you the status / line protocol. So this is nothing but your layer 1 status, and this line protocol is a status 2. Now if you're seeing it's up and up, that means interface is up, it is operational and is working fine. If you're seeing the status of the interface at administratively down, that means your interface is shut down. Somebody have made that interface shut. So what you need to do, if you want to make that interface up, you need to do no shutdown. If you're seeing it down, that means your layer 1 is down, and since your layer 1 is down, your layer 2 is going to be down. If you see it is up / down, that means your layer 1 is up. There's some issue with your layer 2, which is data link layer. So there's some mismatch in the data link layer. Now, when you talk about mismatch in the data link layer, you need to check something known as encapsulation, whether the encapsulation protocol which I am using is correct or not, whether it is matching with the other ends interface or not. So this comes into picture. So this checking interface is again a very important step. Now let's check step number 7, which is ARP. Okay, now let's say I have an IP address 192.168.1.2. Now if I do an ARP lookup, what I'll get an MAC address, okay, which is layer 2. This is a layer 3, right? This is a layer 3 IP address, and this is layer 3 MAC, sorry, layer 2 MAC. So MAC address is always layer 2 and IP address is always layer 3. So address resolution protocol, that is ARP, it basically do is it do L2 to L3 mapping. So ARP translates IP address into physical MAC address. Now, most of times it happens that a particular machine is not able to communicate with the machine or the host in the same network. So, there's some issue with the ARP. So basically, what ARP entry will have is, if you go on Cisco device, and if you give this show ARP, you will find the list where you will get IP address and its associated MAC address. Now, sometimes it happens that there's an incomplete ARP. So only IP address is present, MAC address is not present. So that can cause an issue. Sometimes it happens that two machines have same IP addresses by mistakenly. So, we'll get an ARP entry. You cannot have two MAC addresses against one IP address, right? So that can cause an issue. So I face this kind of issues where I checked on the router, and the machine, there's a user who called me. His machine IP was MAC address was, let's say, A, and I was seeing some other MAC address on that in the ARP table. Okay, so I quickly noticed that some other machine is also using this IP address. So this is something command which you can use while troubleshooting. That is ARP. This is a very important prospect while you are using when you are troubleshooting. The other thing what we can check is DNS. I think in slide number 3, yes, we discussed that we were able to ping 8.8.8.8, but we were not able to ping google.com. So this is what can happen. The DNS, which is domain name system, can have an issue. So I've mentioned over here that if the IP connectivity works but the domain name fails to resolve, you have to investigate the DNS setting and query responses. Now, how will you run the query? The simple command to run the query is nslookupgoogle.com. So this is the query command to run the query. You can go on your Windows laptop and you can check right now. You can get it. So this is basically your DNS IP address. This 53 is nothing but your port number, which is DNS port number. So which is 53. So 53 is reserved for DNS. And then you can check here. So this is the IP address. Sorry, this is the domain name. And this is the IP address. Okay, guys. So yes, you can use this particular command to check your DNS settings. Firewalls or ACLs. Now, most of times you are able to ping, everything looks good, IP address is correct, the route exists, you are able to ping, DNS is working fine, but still the application is not getting connected. So that particular time, as a NOC engineer, what you can check, or as a network engineer, what you can check is security filtering. It may happen like, this is my network. Let's say this is the PC. This is the switch. this is the router, and let's say this is the server. Now this server have an IP address. Okay, I'm able to reach that IP address. This server has a domain name. I'm able to reach its domain name, but still I'm not able to access an application which is let's say working on some port number 80. I'm not able to access that application which is working on this port number 80. So it may happen that this particular router may have an ACL, that is access control list, which may be blocking this particular port, or maybe blocking this particular port for this particular IP address, for the server IP address. Okay, so it may happen. So you have to ensure that whether some rule, some ACL rule is present for that particular destination, or it can be present for your source specific also, that you are not able to access, others are able to access. So you can check whether my IP address is being blocked on the particular router or not, on a particular ACL or not. Now here you can have ACL, you can have a dedicated firewall also. Okay, so you have to check the rules of the firewall. So again, sometimes it happens that the PC will, if you all are aware that your Windows will also have some it also have some firewall, right? So you have to check that also. There's some rules which you can which you can give on your Windows machine, which will filter your traffic. Okay, so of course you have to check. So yes, you can check in multiple ways on your firewalls, on your host machines, on your routers, whether ACLs are not present or not. You can check the security policies. You can check the port filtering, which I told over here. Whether this port has been filtered, denied, or how it is, like whether it is denied or permitted for some specific IP addresses or not. So you can check in that way. So this is also very important on Cisco devices. Yes, you can, on router especially, you can check using this command, show access list. You can check the ACLs. The last step, which is check the system logs. Now this is something which many beginners ignore, but yes, logs can provide extremely valuable evidences. They can reveal your interface failures, your link flapping, CRC errors, or authentication failures, OSPF or BGP, or neighborship flaps or resets, your hardware related errors. So this system logs are something which will tell you what exactly happened before the problem occurred. So these are the few things which I have mentioned. It can give you the interface failures, authentication errors, routing protocol logs, and hardware issues. Also, you can check whether the SFP is faulty on fault is been logged or not. You can check in your system logs. Now most of the beginners, basically, as I told, ignore this particular step. I've been always fond of using this particular command, show logging, in Cisco devices. It gives you a very clear logs that what happened at what time. It basically helps you in finding something known as RCA also, that is root cause analysis. So it also helps you in that is RCA. Now guys, this is something troubleshooting command reference. I showed you many commands, so you can go and take a screenshot of this particular slide, and have a copy of this with you while you are troubleshooting. So as I told you guys regarding this golden rule in the start slide, so always check. The very first thing, always check. Always remember that you have to check. So understand the problem first. You check. You test. You use the best tools or the correct tools, and use the targeted test like pings and Traceroute. You can use. You isolate the problem where exactly the problem exists. You fix the problem with whatever necessary solution it is. And of course, you have to verify whether you have to test the network again and verify and make sure that the problem is resolved. So remember this systematic approach, go with layer 1, layer 2, layer 3, layer 4, and of course the layer 7, which is application layer. So this is how a network engineer should have that approach. So these are the golden rules which we told, and of course the best practices what you can have. Remember, not troubleshoot by guessing. Rather, follow this step-by-step approach. Start with physical layer. Verify the IP address. Test the connectivity. Check the path. Check the routing. Check the interface. Check ARC. Check your DNS. Check firewall rules. And of course, finally, you check the logs. So always have this step-by-step approach where you will check, where you will test, where you will isolate, you will fix the issue, and you will verify. So guys, I'll stop here in this video. If you really find this video useful, please do subscribe to my YouTube channel, Network Engineer Stuff. Please do like this video. Please drop a comment and tell me what is your favorite troubleshooting command. Also, let me know if there's another troubleshooting technique which you are aware and you wanted to give an input, and please drop a comment on this video. I'll stop here. I'll catch up in the next video. This is Amar and you are watching Network Engineer Stuff. Thank you.